Okay, so we have in 14.2, number 6, a function f of x and y that's given by some capital A to the alpha, x to the power alpha plus beta, and y to the power 1 minus alpha minus beta. To my recollection, things like this come out of some kind of statistical process. So, probably what did they want us to do? They want us to calculate directional or partial derivatives, right?
Probably f.
Okay, so I want fx and fy. And I should use good notation for at least a little while. So these should be fx of x and y, right? Okay, so how do I get fx?
Oh gosh, this chain.
Yeah, I want to take a derivative with respect to x, right? Okay, so maybe I'll write this, because this is one of our first one of these. So I'm going to write partial of f with respect to x is the partial with respect to x of all that formula, Jess. So I got a alpha, x to the alpha plus beta, and y to the 1 minus alpha minus beta, right? Okay, now which pieces are constant with respect to x?
With respect to x, a of alpha and y of 1 minus alpha minus beta.
Yeah. So I'm thinking here, right? I have a to the alpha multiplied by x to some power multiplied by y to some other power, right? Okay, so the a to the alpha piece and the y to the 1 minus alpha minus beta piece are constant with respect to x, and they're multiplied by x to some power, right? That says I should be able to pull those out of this differential. Right? All that junk is a constant. It may as well be the number 3. Right? So I get alpha to the, or sorry, a to the alpha times y to the 1 minus alpha minus beta times the partial with respect to x of x to the alpha plus beta. Okay, so that's x to some power, right? How do you differentiate x to powers?
N.
Pull the power down, x to the,
N minus 1.
yeah, 1 lower power, right? Okay, so I'm going to write my constant bit here. I got a to the alpha, y to my 1 minus alpha minus beta, and then I got the power off the x, which is
Alpha plus
alpha plus
beta.
beta, times x to the
Alpha plus beta minus 1.
alpha plus beta minus 1. Cool? With me?
Yes.
Was that messy and nasty? Yeah, kind of. Was it particularly hard?
No.
Only to realize what's constant, right? All right, so how about your fy?
Same.
Now knowing this trick? What's constant with respect to y?
A alpha and x of alpha plus beta.
So there's going to be an a alpha, there's an x to the alpha plus beta, right? That's all the constant stuff. And then I need to multiply by what?
1 minus alpha minus beta.
Okay, so you pulled the power off the y, so you got 1 minus alpha minus beta, and then times y to the,
Negative alpha minus beta because that one gets kicked out.
cool, negative alpha minus beta because the 1's cancel. Cool, cool?
Yep.
You guys tried a product rule, or no? Just got nasty?
Well, I had everything except for the exponent, like on the x1, the alpha plus beta minus 1, I had everything except for that.
Yeah.
I figured nothing would do there anymore.
Yeah, so noticing that this is just kind of, right, playing the role of some number is a little bit tough. You guys see that? Is there any exception to that rule?
That's a 1 maybe?
Yeah, so that's the spot where it would be interesting, right? Is what if this is a 1, right? You guys see that? In which case, you would pull a 1 down and then you would have times x to the 0 power. Yeah, okay, so if it was 1, you would get a 1 and this piece would disappear, right?